Hello everyone, we are solving question 34 of GATE 2022 Chemical Engineering paper, and the topic is Instrumentation and Process Control. The question is, a process described by the transfer function Gp of s is equal to 10s plus 1 upon 5s plus 1 is forced by a unit step input at time t equal to 0. The output value immediately after the step input, that is at t equal to 0, is dash. In this question, we have been given the transfer function Gp of s is equal to 10s plus 1 upon 5s plus 1, and then we are providing the unit step input of magnitude 1. So if this is our steady state, that at time t equal to 0, we are providing a step input. The magnitude of this input is 1. So this input, we can write it as x of s is equal to 1, since the magnitude is 1, and 1 upon s. This will be our input. The output value immediately after the step input. So at this point, we have to find what is y. Y is equal to question mark at time t equal to 0. So immediately after time t equal to 0, that we have to find. That is, we have been asked to find y of 0. Now we can use this initial value theorem for this question. So by initial value theorem, we can write that the value of the output at time t tends to 0 plus can be also written as limit s tends to infinity s y of s. So we need to find this y of s and replace it over here, then put the value of s as infinity to find the value of y of t, that is the output value. So transfer function, you can also write it as g of s is equal to y of s upon x of s, and in this case x of s we have been given as 1 upon s, so this will become x of s into 1 upon s. This is y, so that will be y of s will become g of s upon s. We can put this over here and we get limit s tends to infinity s into g of s upon s, that is y of 0 can be written as limit of s tends to infinity g of s, or else we can put the value of s as infinity in this transfer function, that is no, so we can write it as limit s tends to infinity then s plus 1 on 5s plus 1. So this we can also rewrite it as limit of s tends to infinity, then we can bring it out s plus 1 upon 10 not like this. We have to put the value of s as infinity, that is we can write it as 10 plus 1 upon s, and s we are taking common, 5 plus 1 upon s. So over here we can put the value of infinity, this will s will get cancelled out and it will be 10 plus 1 upon infinity upon 5 plus 1 upon infinity. So 1 upon infinity will be 0, so 10 upon 5 is equal to 2, that is y of 0. So the output value immediately after the step input, that is at time t equal to 0 plus, we can write it as 2. So we can report the final answer as 2.